Okay, so in this video we're going to be talking about similar polygons. And this is actually going to be a two-part video, so this is part 1. So polygons will always have the same shape, but they're going to have a different size. So our polygons are going to be similar if the corresponding angles are congruent There we go. Corresponding angles are congruent, and the corresponding sides are proportional. And we'll further explain this later. So the ratio of the corresponding sides, this is called the scale factor. Okay? And if our polygons are similar, then their perimeters, are also going to be proportional. The perimeters being when you add all of the sides together, that total. So, now let's look at scale factor. And notice this little side note over here saying the order matters. That's going to come into account when we look at this example over here. So, what is the scale factor of triangle ABC to triangle DEF? Well, when they say order matters, notice that the first two letters right here are A and B, and the next letters over here are going to be D and E. So we use that to determine our scale factor. So side AB is right here, and the measure of that side is going to be 8. So we're just going to put 8, and then draw a little fraction bar, and then we're looking at side DE over here. Those are corresponding sides. And DE has a measure of 12. So our scale factor is going to be 8 over 12, and that can definitely be simplified because 4 goes into both 8 and 12. So let me just divide both of these by 4. 8 divided by 4, that's going to be 2. 2 over, and then 12 divided by 4, that is 3. So our scale factor is going to be 2/3 when we're looking at triangle ABC and DEF. Now, they change up the letters a bit over here. Well, actually, they don't change the order, but they do change which triangle comes first. So, in this case, we're looking at triangle DEF first, then triangle ABC. So, once again, the order matters, so look at DE first, which is 12. So we're going to have 12 over, and then AB is 8, like we said earlier. So we have 12 over 8. Once again, we can simplify it. We already know that 4 goes into both numbers. So 12 over 8 is just going to simplify to 3 over 2. So this is what they mean by they say the order matters. They're talking about the letters, the order of the letters within the triangle, and then the actual order of the triangles. It all matters. Now it says, what is the ratio of the perimeter of triangle DEF to triangle ABC? Well, the perimeter of triangle DEF, when you add it all together, it ends up being 54. That is when you add 12, 15, and 27 together. You end up getting 54. That's our perimeter. Fraction bar. So then when you add 8, 10, and 18 together, you're going to end up getting 36. So it's going to be 54 over 36. The largest number that's going to go into 54 and 36 is actually going to be 18. So I'm going to divide both of these by 18. And when you do that, you're going to end up getting 3 over 2. There we go. And notice that these two numbers, they are the same. So the scale factor of triangle DEF to triangle ABC is going to be the same as the ratio of the perimeters of DEF to triangle ABC. Sounds great. So now, looking at this box down here, similarity statements. The symbol, when we're talking about similar polygons, it looks like a little squiggly. If you remember, for congruent, when we were talking about shapes that were congruent, we used this shape right here. It was a double squiggly. So if they're similar, it's just a single squiggly. So a valid similarity statement must match the corresponding angles and sides. So let's write a similarity statement for the two triangles up here. So we can write it as such that triangle A, B, C, this guy up here, and remember the order of the letters matters, is going to be similar to triangle D, E, F. Easy enough. So now let's look at an example. We got triangle JKL and triangle PMN. So we need to list all of the congruent angles and then write a proportion that's going to relate the corresponding sides. So let's look first at angle J right here. Looking at the order we have up here, J comes first, and on the other triangle, P comes first. So we can safely assume that J and P are going to be congruent angles. So right here, angle J is congruent to angle P. So now, let me erase these circles right here. This right here. Okay, so now let's look at K right here in the middle. M is in the middle for the second triangle. So then angle K has to be congruent to angle M. Let me make this a little neater. Okay. And by the way, this is another symbol that you can use for congruency. So where it has a slash or the squiggly with an equal sign underneath it, you could use either that or the double squiggly. Doesn't matter. It's the same thing. So now, once again, erase, erase. And last but not least, we have angle L. L is listed last in the first triangle, and so is N. So then we can safely assume that angle L will be congruent to angle N. So now, let's write a similarity statement. So, we could actually use, but not a similarity statement. I apologize again. It's a proportion that's going to relate the corresponding sides. So, let me erase my little markings that I have up here. So, notice in our first triangle, J and K come first, so therefore it's got to line up with PM. So we would write that as follows. Sides JK is going to be proportional to PM, so equals. And then we have the two last letters, KL, and that's got to line up with MN. So then we can write KL is going to be proportional to MN. There we go. And lastly, we have to deal with the outer and the two outer letters. So therefore, JL will be proportional to PN. So therefore, we have written a proportion that is going to relate all of our corresponding sides. Alright, last example. So now we're looking at these two kind of conjoined triangles. But we can still go about it the same way. Look at the order. So X and R both come first. So therefore we can safely assume that their two angles are going to be congruent. So we can write it as such. Angle X will be congruent to, that's a B, angle R. So now look at the middle letters. We have Y and Y. Funny enough, we get Y in the middle again. Well, Y is its own angle. So it might seem silly to say Y is congruent to Y, but it's just part of the problem, because we know that an angle has got to be congruent to itself, right? So there's the middle letters. Now let's do the last letters, which are going to be Z and S. Right there. So then we can also say that angle Z will be congruent to angle S. Now let's write the proportion that's going to relate the corresponding sides. So once again, look at the order up here with the triangles. So X and Y are listed together on the first triangle, and then R and Y are listed together. So therefore we can go over here and say X and Y is going to be proportional to R, Y. And then I'm going to look at the two last letters, YZ and YS. So then we can say that YZ is going to be proportional to YS. And now we need to look at the outer letters. So that would be X and Z, and then R and S. So therefore XZ will be proportional to RS. And that's it.